by entering the appropriate client data into each row, and the client renter relation is defined as followed. You will define a new. Now you can notice the difference between this table and the last table that you have seen. This is the last table. Here you are having two client names in one column itself, which is the unnormalized form, but in the next table you can see all the information which is stored in the database is normalized. Here each and one column is containing only one value. What is full functional dependency? It indicates that if A and B are attributes of a relation known as R, then B is fully functional dependent upon A. If B is functionally dependent upon A but not on any proper subset of A, a functional dependency A belongs to B is partially dependent if there is some attributes that can be removed from A and the dependency still holds. It will be known as partial dependency. Next is second normal form. What is second normal form? The second normal form is a relation that is in first normal form, and every non-primary key attribute is fully functionally dependent upon the primary key. For a relation to be in second normal form, it should satisfy all the rules which are implied by the first normal form of the normalization, and moreover in that table all the non-primary key attributes, all the attributes that cannot uniquely identify your table, the information stored in your table, they should be fully functionally dependent upon the primary key but not on any other attribute. The normalization of 1NF relations to 2NF involves the removal of partial dependencies. If a partial dependency exists, we remove the functionally dependent attributes from the relation by placing them in a new relation along with a copy of the determinant. In second normal form, what you have to do is you will remove the partially dependent fields to another new relation. This is the method that is used in second normal form. After removing the partial dependencies, the creation of the three new relations called client, rental and the property owner. Earlier in the second NF we had two relations. Up to first normal form we had only one relation, after that we had two relations, but in second NF you will be having three relations. Now you have separated the information of client and the property and the property owner rent as well. So we will be having three tables. One is client, which will be store the information of client number and client name. Then we will be having a table named rental, which will be storing information of client number, property number, when the rent started and when will the rent finish. After that the information about property owner. It will store the name of number of property, property address, rent, owner number and owner name. So we are having three relation basically. Third is third normal form. It will be having transitive dependencies. Now what is transitive dependency basically? It is a condition where A, B and C are attributes of a relation. Suppose we are having a relation R and there are three attributes of that particular relation A, B and C, such that if A belongs to B and B belongs to C, then C is transitively dependent upon A via B. It is provided that A is not functionally dependent upon B or C. So this is the third normal form. A relation that is in first and second normal form and in which no non-primary key attribute is transitively dependent on the primary key, that will be considered in third normal form. The normalization of second NF relations to 3NF involves the removal of transitive dependencies by placing the attributes in a new relation along with a copy of determinant. In third normal form, you will remove all the fields which are transitively dependent to another table, and you will have to name that relation and provide it a primary key. After the compilation of third NF, you will be having 4 tables: client, rental, property owner, and apart from that you will be having another table known as owner. Next is Boyce code normal form, BCNF. A relation is considered to be in BCNF if and only if every determinant is a candidate key. What are the candidate keys which can uniquely identify information in your database? To a relation to be in a BCNF form, every field of that particular relation should be a candidate key. That means each attribute should be able to identify the information uniquely. The difference between 3NF and BCNF is that for a functional dependency A belongs to B, third NF allows this dependency in a relation if B is a primary key and A is not a candidate key, whereas BCNF insists that for this dependency to remain in a relation, A must be a candidate key. This is the example of BCNF. Next is fourth normal form, multi-valued dependencies. It represents a dependency between attributes, for example A, B and C, in a relation such that each value of A, there is a set of values for B and set of values for C. However, the set of values for B and C are independent of each other. A multi-value dependency can be further defined as being trivial or non-trivial. Next is fifth normal form, which includes the lossless joint dependency and joint dependency. A property of decomposition which ensures that no spurious tuples are generated when relations are reunited through a natural join operation. Whenever you are joining two tables, there should be no loss of data. Such a situation will be known as lossless joint dependency. And the joint dependency is, it describes a type of dependency. For example, for a relation R with subset of the attributes of R denoted as A, B and Z, a relation R satisfies a joint dependency if and only if every legal value of R is equal to the join of its projections on A, B and Z. So whenever you are joining two tables with no loss, it is known as lossless joint dependency, whereas the joint dependency is simply a type of dependency. Next is denormalization. What is denormalization? Basically, the database which are intended for online transaction processing are typically more normalized than databases intended for online analytical processing. These are two types of databases which are used in organizations. One is OLTP, which stands for online transaction processing, and second is OLAP, online analytical processing. In OLTP you simply store the information for transactions, but in OLAP, which stands for analytical processing, the information which is stored in your database should be analyzed to derive new results. OLTP applications are characterized by a high volume of small transactions, such as updating a sales record at a supermarket checkout counter. ATM is also another example of OLTP applications, basically because it involves the transactions. The expectation is that each transaction will leave the database in a consistent state. In such a situation where you are using OLTP, each transaction should be done in such a way that it makes no inconsistent changes in your database. That means that the information which is stored in your database should be accurate even after performing that particular transaction. By contrast, the databases which are intended for OLAP operations are primarily read-only databases. As I told you earlier, OLTP is used for transaction processing, where you have to store the information and later on you can delete the information as well. But in OLAP, which stands for online analytical processing, the information is basically read only. They are treated as archives only, because which is the information which is in your databases can be used to derive results. It can be analyzed and the results can be derived from that analysis. OLAP applications tend to extract historical data that has accumulated over a long period of time. The information which is stored in your OLAP applications is of basically a long period of data. For such databases, a redundant or denormalized data may facilitate business intelligence applications. Specifically, we would say dimensional tables in a star schema often contain denormalized data. The denormalized or redundant data must be carefully controlled during ETL processing, and users should not be permitted to see the data until it is in a consistent state. So, in denormalized data, basically you can call the redundant data the denormalized data, because if the tables are not normalized, they must be having redundant data, and moreover the data must be inconsistent as well. So, it should be carefully controlled by the users, by the system analyst during the processing of your data, and the user should not be permitted to see the data before it is in the consistent state, because by using the inconsistent data, user may derive wrong result from that information. The normalized alternative to the star schema is a snowflake schema. You can use it in denormalization. Denormalization is also used to improve the performance on smaller computers, as in computerized cash registers, since these use the data for lookup only, which is price lookups. For example, if you have to check the prices of all the equipments which you are having in a shop, no changes are to be made to the data, and a swift response is crucial. In such situations, you can use denormalization and the redundant data, which is inconsistent data. So, that's all for today. Thank you.